So good evening, everyone.
Good evening, sir.
So I hope you have downloaded and installed R Studio, everyone.
Yes, sir.
Yeah, downloaded, but R Studio, the version is 1.4.1.1, it is showing. So I have installed from the provided link, but the version is not showing the updated one.
Sir, I am installed R programming 4.5.1, but R Studio not installed at this time.
Why?
Sir, R programming 4.5.1 and
R Studio.
yes, sir. But sir, this time R Studio not installed.
So
I have shared screen. Can you share my screen?
why you have not installed? I'm asking. What is the problem?
Sir, problem in my laptop because no storage.
Okay.
Sir, because my laptop is very low storage and memories.
Yeah. So I will
Sir, because my
revise
laptop has
quickly. I will
only
revise quickly
less.
whatever we have covered yesterday.
Yes, sir.
Meantime, I have shared some Excel files in WhatsApp group. Just you can download it. Download it and put in your working directory whatever you prepared folder yesterday. Keep in that.
Yes, sir. Sir, please check my. Sir, this one.
So we are doing analysis in our studio, not in our program.
Okay, sir. Okay, sir.
So yesterday we have started the analysis with RBD. So for that, this was our data file. Here total 13 columns are there as I have told yesterday. So first column is genotypes, second column is replication, and from third column onwards, our observations are there. So total number of columns are 10 plus 2, that is 12 columns are there. Sorry, 13 columns are there, 11 plus 2. So this is what we have installed. This is our R Studio. Hope my screen is visible to everyone.
Yes, sir.
Yes, sir.
Yeah. So this is what we have installed yesterday, R Studio. So in that, first step is we need to install. We installed one package. So this is our script. So we installed yesterday one package called variability. So now today again no need to install. Just we need to run the library command. Just you need to run the library command. After that, go to import dataset from Excel. Just browse it. Go to the folder where you have saved that Excel file. That is your input data file. And just import it. After that, the most important thing is you need to set the working directory where the software will give you the output files. So how to set working directory? Just you need to go to session tab. Here one option is there, set working directory. So from that you need to choose working directory. And then in my case, I have desktop as my working directory, so I will select desktop. So okay, we have run the library command for the respective package. We have imported the data file and we have set working directory. So now after this, we can start the analysis. So first is estimation of genetic parameters. So simply we will copy this first line and we will paste it. Here we need to do some edits, like our file name and whatever the names we have given for our columns. So first our file name is traits. So in place of word data, we will type traits. So here it is given 3:11. But our total observations are 11 and total number of columns in our Excel file is 13. So it is 3:13. Then here also in place of word data, we need to type traits. And here it is first column is genotype. Then here also in place of word data, we need to type traits. So this is the command line for genetic variability parameters. So it is like our file name is traits. In that traits file, we want the analysis from column 3 to column 13. And whatever the other factors are there, first factor is genotype and second factor is replication. So just we need to press enter. After that, to get the output file, we need to copy this. So likewise, we will get the output file. So this output file will come in your working directory. So I think up to this, everyone completed yesterday. So now just open this output file.
समझ नहीं आ रही कुछ.
So just you can open this output file.
सुनो विनिशुट कहते हो कि ये पढ़ती रहती है हैं? कौन कहता है?
So everyone open the output file. So just see. So everyone have this output file?
Yes, sir.
Yes, sir.
Yeah. So just see here.
Not yet. Please give us just a minute or two.
Yeah.
Okay.
Hello. Actually, when I put this command, it is the output file is shown in that respective working directory, but
Yeah.
not in the script as you have shown here. After entering the last three lines,
Yeah.
it is also seen in the R Studio, but in my case, it is directly saved in the directory as a text file.
Yeah. Sometimes it will come in environment, sometimes it will not come. So that is not a matter, sir.
Okay.
So here in this output file, you will get trait-wise ANOVA and trait-wise variability parameters, along with significant or non-significant, along with significance level. So those who have this output file, just you can see here that significant codes have already given. Like 3 star, 2 star, 1 star and dot. Significance level between 0 to 1. After each and every ANOVA table, you will get this significant codes. So everybody completed?
Sir, I saw mine on the desktop. Just on
Yeah,
my
just
desktop.
open it. Open it.
Okay. Okay.
So now, here we can see first is analysis of variance table. So in that, as I have already told you, analysis of variance. So what is the use of this analysis of variance?
It divides the variation in various 3 different components.
Okay.
Whether we are having significant result or
Yeah.
not.
So whatever the variations are present or differences are present, analysis of variance will give us whether those variations or differences are significant or non-significant. So that is the importance of this analysis of variance table. So in that, this variation will be divided into 3 components, or you can say sources of variations are 3. So first one is replication, second one is genotype, third one is residual, or you can say as an error. In then next column, you will get degree of freedom. Next column, sum of square, then mean sum of square, then F value. And in last column, probability with F value. So we will see one by one. So what is meant by replication?
It is a repetition of work. Repetition of treatment.
Repetition of treatments or repetition of genotypes. Then
To reduce the effect of extraneous variable.
yeah. So here you can see in the first analysis of variance table, we got significance level, high significant level for genotypes. So sometimes if we have at some extent, if the data is manipulated, and sometimes if we will get the significant level for replication also, so whether that genotype, whether that data will be acceptable?
Non-significant data, they won't accept.
No. What I'm saying is, here you can see significant for genotype, but along with this, if you will get significance level for replication also.
No, it is not valid.
So if like
No, sir, in that condition, we cannot take it.
So as you can see, you can go through the total file, you will get significant for genotype only. So what I means, whatever the variation or whatever the differences are there in those 44 genotypes are significant across all the traits. So that means presence of ample amount of variability is there in your panel. That is, whatever the material you have evaluated, in that significant amount of variability is present. So that is the meaning of this significant level. That is the interpretation of this output file, analysis of variance table.
Please, can you take that again? Can you explain that again?
So simply, analysis of variance will divide the variation into three different components. First is replication, second is genotype, third is error, or you can say as a residual. So if we have evaluated some group of genotypes or group of treatments, and if we will get the differences significant for genotype, then we can conclude that the amount of variability present in our breeding population or whatever the treatments we have tested having significant variability. So here generally we have seen in our papers 5% 1 star and 1% 2 star. But if you analyze with this R, you will get one more option. Actually, two more options. 3 star, 2 star, 1 star dot at 0.1%. So this is the, so just you have to keep in mind this significant quotes. So in genetic parameters, you will get standard error, critical difference at 5% and critical difference at 1%. So critical difference means differences between treatments or replication. What is meant by critical difference? Difference between treatments or replication.
Treatment, sir.
Okay. And what about standard error means what?
Replication.
Mean. Standard deviation of mean.
Yeah, come again. So standard error is average error around the mean value. So that means whatever sometimes environmental error. So that means in one word you can say whatever the uncontrolled variation is there, that will come as a standard error. So here you can see one more thing is there. Now you have standard error and critical difference at 5%. Right? So just observe standard error and critical difference at 5%. So whether you can see any relation in between those two components, you can see for all the traits. Not just I'm showing for first flowering, you can check with all the traits, standard error and critical difference.
Sir, always CD level is the double the value of standard error, sir, approximately.
Not doubled, madam. Your answer is correct, but not doubled. It is approximately thrice.
Thrice.
So
Okay,
here see standard error is 0.17 and critical difference is 0.49. So it is approximately thrice.
Okay,
so
sir.
likewise you can check for all the characters. You will get approximately same result. For all the traits, you will
So,
get the
sir,
same result.
standard error is due to uncontrolled parameter, and critical difference is due to treatment.
Whatever the differences in between among your treatments.
Okay, sir.
And one more thing, that is coefficient of variation. That is, we used to call it as a CV. So that CV is due to whatever the differences are there in between your replication. So these are the three things: standard error, critical difference, and coefficient of variation.
Sir, what does mean standard error is equal to 0.1729? What does it represents?
So that's what I'm saying. Whatever the uncontrolled variation or whatever is the, in general term, you can say sampling error. So that we used to call, in our general communication, we used to say human error.
Does it mean 70% is due to the human error?
17.
0.1729.
Yeah. Then the genetic parameters. So here you can see genetic variance and phenotypic variance. So genetic variance means whatever the variation that is due to genetic differences, that is called as genotypic variance. Phenotypic variance means total observable variance. Then third is, then next, coefficient of variation. So first three is, see, environmental variance, it is due to environment. Genotypic variance, it is due to genetic differences. Phenotypic variance, it is the total observable variance. Then environmental coefficient of variance, genotypic coefficient of variance, and third one is phenotypic coefficient of variance. And then next we will get heritability. Here and one more thing, whenever you will analyze these genetic parameters through R, you will get heritability like this, 0.99. So that means heritability percentage is 99.6%. Here in this case, heritability percentage is 96.1. So here heritability percentage is 87.6. So likewise it will come. But in your output file, it will come like 0.87. And next is genetic advance. So what is meant by genetic advance? Yes? Yesterday we have discussed this.
Improvement in the mean value of
Expected
selected
improvements
individuals.
through selection.
Yeah, whatever the expected improvement through selection, whatever the selected individuals are there, So in that individual, what is the expected improvement? That is called as genetic advance. And then next is genetic advance as a percentage of mean. So what is meant by GAM? So genetic advance as a percentage of mean means genetic advance expressed relative to the mean of comparable trait. Whatever the traits we are studying, so it is in relation to the mean value of those traits. So likewise, you will get analysis of variance
Excuse me,
and
sir.
genetic parameters. So now,
Excuse me, sir.
yeah,
Sir, is it same as genetic gain or different from that?
yesterday only I told genetic gain, genetic advance and selection differential, all three are different.
So genetic advance is percentage of mean.
Genetic advance means whatever the expected improvement in your through selection, that is called as genetic advance. And whatever the rate of improvement, that is genetic gain. And whatever the differences between the progeny and original population, that is called as selection. That the difference in selection. So all these three are different. So now my question, one question is there. If particular trait is having high heritability and high genetic advance, high heritability coupled with high genetic advance, so whether we that trait is suitable for transfer or not.
Yes.
Yes,
Yes,
suitable.
it's suitable.
If
Yes,
high
suitable for selection.
if high heritability and low genetic advance, then
Needs improvement.
and if low heritability, low genetic advance means,
Selection
Not
will be
suitable.
ineffective for the trait.
yeah. So this is the, in short, in 3 lines, description of genetic variability parameters. So likewise, you will get for each and individual trait.
Sir,
Yeah.
yeah, sir, can you please explain me again how we can tell we have a significant variability through this by seeing this ANOVA table and significant codes?
So here you can see, you just go through the text file, you will get in for all the characters.
Okay.
So for all the characters, you have significance for genotypes. Just go through each and every character. You can see the high significance is there for genotypes. So that means while interpreting, you have to write the amount of variation, whatever the differences are. In other words, your breeding population is having significant variability for all the traits or across all the traits, whatever you have studied. If instead of these genotypes, you will get significant level for replication, then your data will not be accepted. Can anyone tell me why? So why this
Because
case is not
replication
acceptable?
reduces error.
We are not doing that experiment in a perfect manner, sir. That equal treatments and all not practiced in all replications.
Right. So we are evaluating the treatments to study whether our treatments having significant variability or not. So if your analysis of variance for genotypes will come as a significant, then only you can interpret that whether your population is having significant variability or not. So for that reason, this analysis of variance is most important.
Yeah, so you mean this stars is nothing but showing this significance.
Yeah, below analysis of variance, it is given like significant quotes.
Okay.
For that purpose, we have for that purpose, F test is there. F values are there.
Okay. And here standard error of mean critical difference and a variance is there, no? So like what should be the values, what should be these values for any particular genotype or a population, whatever we were selecting, like how we can consider that as a significant or non-significant, whether we select or
here-
reject.
Here, standard error and critical difference is clear thing. Just now, we have discussed like if you will see standard error and critical difference, you will come to know that critical difference is approximately thrice the standard error.
Okay.
In each and every trait, you will see this pattern. If you have any analyzed tables or data, in that also you can check. You will come to, you will see this pattern each and everywhere.
Yeah, that is understood, but like how much should be the percentage? How we will say whether we have to select that particular, whether we will say how.
Significance and non-significance you will get to know through analysis of variance.
Okay.
And whether you have to work on that character or not, that I told like high heritability and high genetic advance.
Okay. So what is this critical difference and standard error representing? Whether we have to consider this data.
So if your variation will come as a non-significant.
Okay.
Then you will get here like it is significant or non-significant. So so if you yeah, so just like I told you, if you will get significance level for replication only,
okay,
then that data will not be considered.
Yes, sir. But my question is like, if this pattern for standard error and critical difference is not same for all the traits, then what it indicates?
So approximately, if your data is showing significant variability, so this pattern will be there.
Okay.
So you can check now. You all are masters, PhDs. You have data. You have already analyzed tables, so you can check.
Yeah, sure.
Excuse me, sir.
Yeah.
Sir, I have one question that as we can see in this result, phenotypic coefficients of variance are slightly higher than genotypic coefficient of
Yeah.
variance. But is there any exact value to decide that they are significantly higher or they are
No,
almost
no, no.
similar?
By like this only, you have to consider your phenotypic variance should be higher. Will come always. Your phenotypic variance should be on the higher side.
So, but the difference is very less in between both the
No
values.
problem. Sometimes for some traits it will be like 0.011 and 0.012.
Okay. Still,
Or
we will say that
sometimes no,
value
no,
is
no.
higher.
It is, see, this is like doing farming, and for farming there is no thumb rule.
Okay. So that means that still
Whatever the outputs you will get from that, you have to do interpretation.
okay. So sir, here we will conclude that still that phenotypic coefficient of variance is higher than genotypic coefficient of
Yeah,
variance.
yeah, yeah. Because many times we'll used to say like how out of 45 genotypes, only two characters significant, 3 characters, why not others? So as this is experiment, so
Okay.
you will not get each and every character at significance level.
Okay, sir. Sir, and if the values are similar or phenotypic coefficient of variance is less than genotypic coefficient of variance,
Where
so is it possible that PCV will be less than or equal to GCV?
generally 99% it will not happen.
Okay.
Slight difference will be there.
Okay, sir. So if it happens, then our data is wrong or something.
No, no, what I'm saying is 99.9% you will not find that. If it is there, so some mistake is there.
Because phenotypic data represent coefficient of variation represent both environmental and genotypic coefficient of variation. So it will be higher than the genotypic.
It will always be come on higher side.
Okay, thank you, sir. Thank you, ma'am.
Okay, so we'll go towards our next part, that is correlation analysis.
Hello, sir.
So yeah.
Yeah, please. What is the implication of high CV?
Yeah, come again.
What is the implication of ICV? That is coefficient of variation.
That means coefficient of variation means amount of variation present in between your replications.
So if we have a CV of 30%, what is the implication? So that is what I'm asking.
So your voice is not coming clearly.
So I'm asking, if we have CV of 30%, what is the implication?
So that means you have your variation among your replications are on higher side.
So that is low precision.
Yeah.
Thank you.
So for correlation also, same coding line, just see, then you can do it. As we have already imported the data file, so directly we will go towards code. And here we will change the file name. This code is same like whatever we did with the genetic variability. So likewise here, you will get the correlation table. So just you can do it, the correlation analysis. So likewise, this file you will get after completion of like this genotypic and phenotypic. This is for genotypic correlation.
So can we continue in the same output file, or we have to open new RStudio again?
No. In same way as I have copy pasted, in the same environment, you have to continue. Yeah, madam, just you need to edit the code line. Just you can see the screen.
Okay, sir. Okay.
Sir, from where I can copy this code?
It is there in that yesterday what code file I have shared now. In that same file, it is there. Genotypic and phenotypic correlation.
Yes, sir. I've done it, but I just want to know how to copy in Excel from the text, because it is not showing in one. It is just like two strangers. Yes, same file you have, whatever you have showing. It's like that.
So this is your genotypic correlation.
Okay, thank you.
So here then you can change it. Yeah, and before starting, you need to run the library variability command. If not done, then do it.
Sir, I did mine, but it's not giving me what you have.
So have you run the library command for variability?
No.
Then run it.
Okay.
So correlation graphs, cluster analysis graphs, whatever the graphs are available in crop improvement, so we will take in one separate class. So don't worry.
Sir,
Yes.
could you please explain once again?
So simple, just you need to call just this file, whatever the file I have shared yesterday, in that same file, genotypic and phenotypic correlation codes are there.
Yes.
So simply you need to copy and you need to edit like we did for genetic variability. Same way you need to edit this code. For Excel, go in data tab of blank Excel. From text, then select the required file, that is GenCore, import it, and then adjust these columns. You have to adjust these columns and then import it.
Yes, sir, but during importing the data from text, adjustment is not showing in my Excel. It is my person is 365.
Oh, that new version.
Yeah, it is little bit different. I think something showing different.
I think you have some option like transform into table. Like something option is there.
Okay. I will find, sir. Okay.
Sir, it's still not giving me.
What happened?
I don't know. Can I share my screen with you? Can I share my screen?
What is the error?
Pardon?
What is the error?
I don't know. I run the codes, but it's not giving me.
Just show me.
Okay.
Sir, whether I have to run all the codes which we have used yesterday before running this correlation
No.
codes?
For correlation, just you need to run library command and directly you can start the correlation.
Okay,
Hello,
okay.
sir.
Yes.
You see, this is what I have.
So it is already completed now. Just you can go through, go to your working directory.
How do I go to
Have
my
you
working
set
directory?
have you set the working directory today?
No. Oh, I have to set it
Ah,
today again.
yeah. First,
Oh.
everyone before starting, first you have to set working directory. Daily you have to set the working directory.
Okay, is the same working directory as yesterday, right?
Yeah, whatever we did yesterday, by same way you have to set again.
Oh, thank you.
Excuse me, sir.
Yes.
Sir, the TXT file after the genotypic correlation, it shows genotypic as well as phenotypic correlation both. So do we have to?
Yeah.
So do we have to run both phenotypic and phenotypic correlation and genotypic correlation? The file you have shared us, because after
Yeah.
running genotypic correlation, we can get both the correlations.
You have to run both.
Both, but the results are same. So
results are same.
Okay.
But sometimes what will happen now, if you will not run this phenotypic, then in that text file only you can see later on only genotypic one.
Okay.
Sometimes phenotypic it will not come.
Okay, sir. Thank you.
So see here on the screen, you have to go to session. You have to go to session, then set working directory option is there. Just you have to click, then choose working directory option, and here you can say select any of the folder available in your computer. In my case, desktop is my working directory, so I will click on desktop and I will click open. So likewise, you have to set the working directory. Yeah, for cleaning the console, Control and L. You have to use Control L. Your console will be pure white. So everyone got this output file?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Here,
Yes, sir.
just you can see.
Not
There
same
are
with me,
different.
sir.
Do it.
No, sir.
No, sir.
Yeah, Murthy sir, you have which word? Microsoft 365 or older version?
I set my working directory. I ran the library, entered the code for the genetic variants, but still it's not giving me.
Have you edited the code? That is your file name 3:13.
Yes, Prof.
Then go to your working directory, it will be there.
Okay.
So generally this correlation means we will come to know the relationship between different traits. And this correlation coefficient, as you may have aware, it will lie between -1 to +1. If it is more than +1, means your manipulation is wrong. If your data you have recorded correctly, then it will be in between -1 to +1. So here you can see, first we'll talk about grain yield per plant. You can see it is showing a positive and highly significant correlation for almost all traits, except these two. It is showing significant correlation for almost all the traits except biological yield and the CTL. So likewise you have to interpret it. Which character is having positive significant correlation, which character is having negative significant or positive non-significant and negative significant. So likewise, by each and every aspect, you need to write the interpretation.
Sir, one thing, sir. Can we use the term like independent variable like this, sir?
For what?
Sir, for the correlation, can we use any term like independent variable like this?
Your
Like
voice,
for a particular.
voice is breaking.
Yes, yes, sir. Is it clear, sir? No.
Now it is clear.
Yes, sir. Yes, sir. Like in correlation, will we use that word like the term of dependent variable? Like for example, if it is yield, we are correlating with the. Yeah, yes, sir. Yes, can you please clarify that thing, sir?
So generally see this like grain yield. So this grain yield is depend on many characters. Like suppose in if we'll take example of any vegetable crop or any crop, grain yield or fruit yield is depend on many characters. Like let us take example of okra, number of nodes, internodal length, number of fruits per plant. So all these three traits will ultimately affect the fruit yield. So likewise, in this terminology, number of nodes, internodal length, and number of fruits, these three are independent. But your fruit yield is dependent variable on those three traits.
Yes, sir. Yes, sir. Yes, sir. Got it, sir. Thank you.
It is like that.
Yes, sir. Yes, sir.
So likewise, in that same terminology, if you will run correlation, you will get like number of fruits per plant is having positive and highly significant correlation with fruit yield.
Yes, sir. Yes, sir. Got it.
In the same way, you will get internodal length will be negative highly significant with grain yield. Now why? Why internodal length is having negative and highly significant correlation with grain fruit yield? Anyone?
Yeah, I think hello, sir.
Yeah. Tell me.
Because
So, as a,
it reduces
Anyone, please, anyone.
So the implication is that as the internal length increases, then fruit yield decreases and vice versa.
Yeah. So
qualitative.
less internodal distance is significant for crop improvement.
Yes.
So that is the meaning of this positive significant and negative significant correlation.
Sir, how you got this data in Excel sheet? Whether you have copied it or we can export it.
Madam, which Microsoft version you are having? Whether it is latest one or older one, it is same like me or different one?
Same like this only.
So just simply you need to go to data option is there, madam, at the top. Data option is there.
Okay.
And from that data option, you need to go to text. This third option is there.
Okay.
Then you need to select the file, click on import.
Okay. Okay. Okay, sir.
So likewise, you have to follow the steps.
Okay. Thank you.
Excuse me, sir.
Yeah.
Sir, I have the older version, then how I have to copy the data?
Same. No, same. Whatever I told us, in the same way you have to follow. So just now, whatever I have told, so this is the meaning of this highly significant, positive, negative. And again, one like this internodal length. So just anyone can tell the answer whether days to 50% flowering. So just like we told, like internodal length is less, that will be significant for crop improvement. So what about days to 50% flowering or days to first harvest?
It will be negative correlation with granular. Negative correlation with granular.
Yeah, so that means the early hybrids or early varieties are beneficial for us. It will give us more yield. So this is likewise, we need to interpret this. This is the interpretation. This is the actual interpretation of this table. So likewise, see, more plant height, more plant height, less internodal width. Yeah, so here, more plant height, less internodal distance, more number of fruits and high yield. So likewise, I have correlated 4 characters in one sentence. More plant height, less internodal distance, more number of fruits, more yield. So in that again, if I need to add one character, more plant height, less internodal distance, more number of fruits, more fruit weight on higher side, ultimately the fruit yield will be more. So this is what the correlation is all about. So in the same way, now we will see the path coefficient. Yeah, so that was that. I think Alok raised that question of dependent and independent thing. So in this path coefficient, you will came across this like say, whichever is dependent variable, it is mentioned separately. And whatever the independent variables are there, those are mentioned separately. So likewise, this you need to edit traits. In our case, our dependent is 13 column. And rest are 3:12. Rest is same. Then now I will export this in Excel so that you can get through it easily. Yeah, Manoj, which library you have to run? Yeah, so like this, just run the path analysis code.
So we can run in continuity as it is
Continuity in
showing like that.
same console you can continue.
Sir, how can we clean the earlier analysis?
Control L. If you will press Control L, that console will be clear.
Okay.
Just like this. Just run genotypic and phenotypic both.
Sir, I have a question.
Yeah.
Sir, do we need to set the directory again if we clear the console?
No. Before, no. After clearing also, the directory will be there. But now if you will close it today and if you will open it again tomorrow, then you have to set up working directory. It is same with library command also. If you will clear console, no need to run library again.
Sir, actually one question, sir. So what is the difference between genotypic and phenotypic correlation?
So your voice is very low. Just you can speak.
What is the difference between genotypic and phenotypic correlation?
So it is like, sir, at genotypic level and at phenotypic level it is there. So that means, suppose as now we have we have discussed like this, suppose this days to 50% flowering is having positive and highly significant correlation among the two characters in genotypic correlation. So genotypic correlation measures the association. It will tell us the correlation between the two characters influenced by genetic factors. And in same way, in phenotypic table, again the result will be like some positive significant or positive significant or positive highly significant. So it measures the phenotypically, whatever we have total observed the phenotypic observations. So it will depend on that. And in this genotypic correlation, it will depend on genetic factors. Okay, got it. Same like in genotypic and phenotypic path coefficient also. So majorly in phenotypic, environment will play major role with a small amount of genetic factors.
So here we have to take column from 3 to 13.
No. For path analysis, your dependent variable is 13th column, and then if you will delete the 13th column, then you have to take 3:12.
So we have to delete 13th column.
No need to delete, just see the screen.
Okay, sir.
And those who have done genotypic and phenotypic correlation, just you can observe both the tables. You will find genotypic correlations are somewhat on higher side than phenotypic correlation.
Sir, please, how do I export it to the Excel sheet?
So which Microsoft version you are having? Whether it is same like this my screen or it is different?
No, it's the same like this.
So simply data tab, then from text, and then just follow the procedure. Whatever the options will come, just follow it and adjust the columns.
Okay.
Yeah, so in path analysis, everyone got this table?
Yes, sir.
Yeah, so just see the screen.
Yes.
So we did genotypic path coefficient analysis over grain yield. So that's why grain yield character will not come in path coefficient. So here you can see these are the diagonal values. So diagonal values will consider as a direct effect or indirect effect.
Direct effect.
Direct effect.
And on either side?
Indirect effect.
Yeah, so these are the direct, so means these diagonal values means the character, this value is having direct effect on grain yield, and on either side it is having indirect effect. So one more way, if you will select this, suppose days to first flowering, if you will select this whole row, at the right side bottom you can check the sum of this all total numbers. The sum of this all total numbers is equal to the correlation value. Those who have successfully exported in Excel, just they can check. If you will select this row, sum of all these numbers is equal to the correlation of grain yield per plant with DFF. Both the numbers will come same.
Sir, what is direct and indirect effect, and how do we say diagonal values are a direct effect? Sir?
So for that, you need to go through path analysis concept.
Okay.
So direct and indirect effect means, like first, before this, we studied the relationship between the characteristics. Like there are several characters: plant height, node, number of fruits per plant, fruit weight, grain yield. So I listed 5-6 characters. All those 5-6 characters will develop a particular certain amount of variation among your breeding population. Correct?
Yeah.
Yeah. So whether plant height will directly affect the grain yield?
Yes.
100%?
Yeah.
Yes, sir.
Then internode, number of fruits and fruit weight. So that means whatever the characters I have enlisted, those characters are directly affecting the grain yield. So likewise, this is the relationship between the two characters. So now whatever the variations are there, this path coefficient will divide into two parts. That is direct effect and indirect effect.
Okay.
So direct effect means, like see, number of fruit per plant, more fruit, more yield. Likewise, we'll see. But if more fruit and less fruit weight, so then what about yield?
It will be reduced.
Less or more?
Less.
Because of which character?
Fruit weight.
So, in spite of fruit, number of fruits are high, but via fruit weight, it will affect the grain yield.
Okay.
Or fruit yield. So that is called as indirect effect of fruit weight on grain yield.
Okay.
Generally, we will say high number of more number of fruits, more yield. So this is direct effect.
Yeah.
So this is the direct and indirect effect.
Yeah, it is clear now. Sir, what is this last values with the
This is nothing but the This is nothing but the correlation value. Just you can check the genotypic correlation table. You can see this value.
Okay, okay. You mean path analysis will give this correlation value also?
Path analysis is nothing but the extension of your correlation analysis.
Okay.
So sum total of these path coefficients should be equal to the value in the last column.
Yeah. Just see, I have selected this total row. If you can see here, you will get the value of this correlation.
Thank you, sir.
Here, 0.618. It is the same. For this also, if you will select this, 0.603. Then next, 0.288. So this all things will depend on how accurately you have recorded the data in field. So doesn't matter whatever the number of technologies will come, still artificial intelligence, everything will come. But ultimately there is no replacement for recording data in the field. If your data in the field is correct, you can use any technology. So likewise, you can check with your phenotypic path coefficient also.
Sir, how to interpret this data, this table?
So that's what I told. If suppose I have given example like number of fruits per plant, fruit
And
weight, and yield. So if suppose these three traits I need to interpret, this number of fruits are on higher side, fruit weight is on lower side, so ultimately yield is low. So what I will interpret is yield is low because of fruit weight via despite of more number of fruits per plant, fruit weight is low. That's why grain yield is less. So that likewise here you can see days to first flowering is directly related to grain yield per plant via these characters.
Okay.
So likewise you need to interpret direct effect via these characters.
Okay.
So can you repeat, please?
So just effect of days to first flowering on yield via remaining characters. So likewise you have to interpret. You have to interpret character wise.
Okay, sir.
So it means this last last three traits are having less effect.
Yeah, that will that your interpretation will vary whether that effect is negative or positive. So you have to mention it like it is having negative direct effect or positive direct effect or positive indirect effect or negative indirect effect.
Okay.
Sir, if I want to change, don't want to know about the grain yield, want to know about the effect of other traits on days to flowering on plant height, then what are the changes I have to make in the codes?
No need to change, just you have to change the column number. But again, if you want to see this path, again you need to change in correlation also. Then you have to change in place of yield, you need to put any other character, whichever is required. Just you need to change the column number.
Same or what are the column number we have to put in the codes?
It depends on you. Which character you want, so that column number you need to put. According to that, you need to edit.
Okay, sir.
So
this
how
is
to build that graph with this data?
So graphs, madam, we will see in separate session. All total graphs, including cluster, correlation, path diagram, everything.
Okay, sir.
So here, this is all about randomized block design, analysis of variance, genetic parameters, correlation, and path coefficient. Now next, we will see what is principal component analysis. How to do principal component analysis. For that, I have already shared one Excel file with name PCA. So just open that PCA file.
So whether we have to import this file.
Yeah, I will tell. I will tell. Just copy and paste a text file and Excel file in your working directory. If you have already downloaded, just import it. So here, after importing, just you can see, here we have taken only the observations. Serial numbers, it will take directly, that is 1 to
Sorry, sir.
44.
I can't see the screen.
1 minute, 1 minute, 1 minute. Sharing this stuff. So now it is visible.
Yes, sir.
Yes,
Now
it
it is
is.
visible.
Yeah. So just import this PCA file. So here we have taken the mean data. And in that code file, you have to install one more package, that is Factor Extra. So just copy this first command line and paste it and press enter. Installation will start. As I have already installed, I will run the library command. So install this Factor Extra package and run the library command. So in between, if you will come across any error, let me know.
So can you please show the command again?
So how do we understand where to use which package? Are you there, sir?
Sorry, I forgot to unmute. Yeah. So yesterday I told one forum that is GitHub, GitHub.
Yeah.
So as R is open source software, so daily packages are updating, adding of packages, it is happening daily. Many members are working there. So in that forum, you will get this all the details.
Okay, like for what we have to use which package, these all
Yeah,
information.
as far as my knowledge, it is approximately 8 to 10,000 different packages are there for different analysis.
Okay, it means there might be some other package, like using some other package also we can do this ANOVA, whatever we have did earlier.
Yeah, as far as at present these packages are there, maybe it will get updated or maybe new packages will add.
Okay.
Yeah, so installation and library command run done.
Sir, on
Yes, sir.
clicking on installing, it is continuously installing the packages in
Yeah, wait,
my
no
studio.
problem. Wait. In console on right side, you will get one red symbol. Right side corner in console. Just see, first I will show you. So as our file name is PCA, we have all these 10 characters, and this time, instead of replicated data, we have taken mean of all these 44 genotypes. So this is simple. So total this code is already ready. Just you need to copy paste. As here, whatever I have selected PCA, this is our file name. If you will give different file name, you have to edit there. And simply if I will edit.
So we have to copy whole up to bottom.
No. See this.
Okay, sir.
Sir, can you please repeat?
Sir,
Copy
there's a
this,
problem
whatever
in
I have
installation.
selected. Whatever I have selected, copy, paste in console and press enter. Yes, madam.
Sir, I have a problem in installing only.
What is the error?
Sir, this art, then it is trying URL, HTTP, RStudio, Windows, contribute something, and there are multiple of those.
So it is continuous, na?
Yes, yes, sir.
Wait, it will continue. After some time, it will
Okay,
take
I have
some
to
time.
wait for it. Okay,
Yeah,
sir.
wait.
Please, sir, can you take this process again?
Whatever I have selected, copy it and paste in console after installation of this package. Have you installed the package?
No.
Install it, run library, and then copy paste this code.
That's the factorial package?
Yeah.
Okay.
That you need to install.
Okay. After running the library, then what next?
Follow these code lines. Installation, library. After library, copy this, whatever I have selected, and paste in console and run.
Can you repeat it again, please?
Copy whatever this selection area you can see, copy all these commands, paste in your console and run.
Okay.
So you have provided in chat box.
What?
These commands.
WhatsApp group.
Okay.
Sir, the package is not installing. There is a message binary source needs compilation. String.
Madam, please, can you share me the screenshot?
Oh, yes, sir.
It told me error.
What type of error?
Okay, let me check. Error, unexpected symbol in something, I don't know. Do I need to set the working directory?
No, not again.
Okay.
Excuse me, sir.
Yeah.
Sir, how do we save these results that are coming here, the eigenvalues and all the contribution
Yeah,
in
yeah,
our
yeah.
working direction?
First let others complete. I will come to that.
Okay, 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 okay. Thank you.
Sir, I have run the command, but the figures as they are coming in your screen are not coming in mine.
So just once again, clear the console or any problem. Just see, go to the session and restart the R.
Okay, sir.
And again, from library, again you need to continue.
Okay, sir.
No need to install package every time.
Sir, can I share my screen?
What happened?
It is not showing actually after pasting, copy paste my FVIJ, whatever in the script. But it is showing different color by.
Share me screenshot on my WhatsApp.
Okay.
Sir, what is this data telling about? What are these values?
Which values?
This data Excel sheet, PCA, like PCA
It is
will.
yesterday. Now just we handled replicated data, so that this is the mean value of that replicated data.
Okay.
So after that, I need to do this.
Sir, I have sent through WhatsApp.
Not came. Now it came.
Sir, your number, please.
So after restarting the session, as I earlier told, you need to start from library command. In between, you can't start. You have to start from 0. That is from library command.
Sir, can you provide your mobile number, please? Hello.
Yeah.
Sir,
It
please
is in chat.
provide your
Chat
mobile
box. My
number.
number. Chat box. My number is there. Yeah. So after that, you will get after running
Sir,
this diagram,
now
yeah,
whatever PCA biplot it is showing in the showing here in the plots, so whether we will get it directly in our working directory or we have
yeah,
to
yeah, yeah, yeah.
export it.
Wait, let me. No, no, no. It will be in your console only. You have to save. It will not come directly.
Yes, sir, I have sent now. You can check.
So just you did copy paste, press
And where
enter so that graphs will come.
Okay.
After pasting, you need to press enter, na? Automatically it will not come.
So we have to first copy this in Excel,
What?
the output for the graphs.
No, no, no. Wait. I will show you. Wait. Don't copy. Yeah. So this, you will get 4 graphs. So here you will see export option is there. So just click on the export option. There are 2 options are there. Save as image, save as PDF.
So
So it's
actually,
better. Huh?
so
In my
actually it is
case,
not
it is,
showing
it
graphs
is
in the
error.
console. It is showing only output data.
This right, like me, on right side.
So on right side, it is showing the working directory folders only.
Click on the plots. There are different options, file, plots, packages, help. So click on the plots.
Okay, thank you, sir. Now it is showing.
For me, it is showing only 2 plots.
So then restart your R and start from library.
Okay.
Sir, I have sent my screenshot in WhatsApp, but it is.
Dr. Saab, have you run the library factor extra command?
Yes, sir.
Sir, I also send you the screenshot.
1 minute. Your screenshot not came, madam.
On your WhatsApp, sir.
No, it will not came. Dr. Saab, just once restart your R and start from library command.
Okay. So factor extra, I need to give inverted comma both side.
Same from library command again you have to start. First restart the R and from library command just complete all the codes.
Okay.
Sir, how can we go from one plot to other plot? It is showing only PCA by plot.
So one by one you have to save it. At a time you can't save all 4, 5.
Okay, sir.
Yeah, so what I'm saying is in export option, just you have to click on save as image. Then here you can give any name. That is, this is script plot. And here you can change the dimension of image also. So here I will make it something 800. Then update. It will be save in your working directory. So like this, you can save your output file, output graph.
Sir, I cannot see my screen plot.
Have you run the codes?
Yes, sir, I have run the codes and PCA biplot is there, and then the other variable PCA is also there.
So here you can see in your computer there are two arrows up and this left side and right side.
Yes, sir. These are only showing two graphs.
So you can use that. If it is showing only two, then run again. You can use these arrows, click on that arrows. Like this I am doing.
Yes, sir. Like this only I am doing, and it is only giving me two graphs like yours, but not that bar graph one. Do I need to run again for this?
Yeah. So see, whatever I have selected, everything.
Sir, I have.
Yeah, Dr. Saab, you need to install ggplot2 package. So for that, you need to go to tools option. Arjit sir. Arijit sir.
Sir, can you please tell how this PCA values help us, how this data helps?
So this analysis completed up to get contribution values.
Graphs are completed.
So complete total codes. Then we will see one by one.
Okay.
For saving all these data, just you need to select this, copy, and you can paste in Notepad. Likewise, you can paste it.
Hello, sir.
Yes, madam.
Sir, when I'm putting the command of eig.val, I'm not getting
Yeah.
the eigenvalues variance, what data you have selected currently. I'm not getting that data.
Just clear the console and run that command again. That command, eigenvalues command only. Clear the console and run again individual line.
Okay, sir. Do I have to run the library command again or not?
No.
Okay.
No.
Thank you, sir.
Sir, can you explain the scree plot?
First, sir, let them complete the analysis, because if in between I will start explanation, many of them still they are unable to draw these diagrams.
Sir, I'm not getting these eigenvalues in the console.
So restart again. So maybe there is some problem from either your software or from your system.
So whether I have to restart for all these graphs and all?
Yeah, yeah.
Okay.
Sir, I have sent you the message. I think my R Studio version is different. That's why it's not working. It is showing
Sir,
4.1.1.
Dr. Saab, in console, horizontally, just go on right side, one stop, red symbol is there. So your analysis is still going on.
Okay.
You need to install one ggplot2 package. It is showing like ggplot2. You need to install. After ggplot2, you can run the factor extra.
Okay. GG plot 2, I have to install like package same way.
Yeah, just like see the screen in tools, install package. This type of window will come. Just type ggplot2. Here it will come and just press install.
From where this pop-up coming?
Tools.
Okay. Thank you.
Install package. Here you can type the required package name and you can click install.
Please, sir, I have this plea. Can you make the videos available so that after the class we can listen to it and follow it up again? Like the recordings and the videos. Please.
Yeah. Today I will update you. No problem.
Okay, because yesterday's own you didn't send.
Today I will update. No problem.
Please. Thank you.
Good evening,
Whether
sir.
we have to see, yeah, please.
Sir, I have sent you a screenshot on WhatsApp. Sir, I have pasted all the codes one by one and press enter, but I don't know why it is showing like this. So please help.
837 number ending with 837. Huh?
Yes, sir.
Yeah, so still it is going on. So just wait. Maybe it is a problem of your system or network maybe. So just wait.
So, sir, do I have to install ggplot?
Why it is showing error?
Here in console, it is showing loading required package ggplot.
Yeah, then you need to install it.
Okay.
Yeah.
So whether I have to paste the code again or it will automatically process it after the internet connection restored.
So you need to, it is processing, just you wait. Otherwise, you need to start from zero.
Sir, I have started from zero once again, but still that scree plot is not coming.
So just once you can close the R Studio and open it again. If anything is not coming, just close it and open it again. So those who have completed, they can just see. Just we need to copy this, whatever the data will be there, and just copy, and you can paste in Notepad. And regarding these diagrams, so now this scree plot will go to this next one. Here, just I will give name. For this kind of diagram, generally you have to, generally means I am telling, according to me, I will keep the width 800 so that this visibility of this diagram will be clear. And these numbers you can see like dense. If you will make it like 1000 or more than 1000, that numbers will be very small. So while printing or while in hard copy, just you cannot identify it. So the width should be 800, and if it is dense, just you can keep it 1000. So now for this biplot, if we'll keep 1000, just see total this diagrams, we can make it clear.
Excuse me, sir. Sir,
Yeah.
it is on right clicking, it is showing only save image as.
Not image. I am saying whatever the data is there, on that data you can right click and copy. For image, you need to click on export.
Okay, sir.
Or else, if you will right click, you can copy the image, open paint option in your system, and you can paste in that paint also. That option is also there.
Sir, on after export, we have to save as image or save as PDF?
It's up to you.
Okay, sir.
So I have started from zero and again pasted the course, but
Just one suggestion, close everything. Close the R, everything. Open R again and run it again. Because I think your system is not taking that load. That's why it is stuck. It is stuck at one point. So this is about PCA analysis. So just to try up to this. We will continue this PCA tomorrow also. Tomorrow we will go for principal component analysis. Again, analysis with interpretation. Then we will go for augmented block design and alpha lattice design. So these designs we will complete it tomorrow. Yeah, Soundarya madam.
Please, Prof, help us send the video recording and this. Please.
Yeah, I will update you in WhatsApp group in short time.
Sir, excuse me, sir.
Thank you.
How to save this graph and data, sir?
So graphs, madam, just simply you need to click on export. One option is there called export. Just you can click on that and save as image.
Okay.
So like this pop-up will come. Here you can give any name. Just like this is biplot. So I will give biplot. And here you can adjust this dimension. So as this is dense graph, I will keep it 1000. After that, I will maintain this aspect ratio. So ultimately, whatever the width you have entered, if you will click on this maintain, ultimately height will be adjusted. And then just you can save it.
Sir, today I think due to version, it is creating problem. I have sending the screenshot. one thing I can do today, I will uninstall the Studio. I can install the latest version as provided you. Let's check
Yeah,
what
yeah.
happens tomorrow.
As we will continue this PCA tomorrow also.
Yes, sir.
So no problem, sir. Yeah,
Yes, sir. That's
Anjali
why I'm
madam.
telling.
Hello, excuse me, sir.
Yeah.
Sir, can you please share yesterday's video? Today was my first class and I don't
Yeah,
know what done yesterday.
today shortly I will update you related to the videos. So don't worry.
Excuse me, sir.
Yeah.
Sir, is it possible to do this PC analysis on qualitative data like flower color and other data?
With respect to which aspect, madam? Or which crop?
Like, sir, in genotypic studies, we record data also like color of flowers, color and shape of capsules and shape of leaves. So, by
As far as
analyzing,
I have not gone through that, but by using this code, you can try once. But for this, one thing you need to do, as that qualitative data, that quality data means will be it is morphological or in quantitative manner.
the morphological manner like color of
So
flower.
for that, if you will give codes, like suppose in some like seed shape, if you have three different shapes, so like 1, 2, 3, if you will give codes, just like we will convert our HapMap file into numerical format. So likewise, if you will convert it, I think you will get this graphs.
Okay, sir. Sir, it's a request if it is possible for you to also teach us that also.
Okay, tomorrow we will take that also, madam. I have quality data, so I will convert into numerical format and then we will take it.
Okay, thank you, sir.
Please,
So
Prof,
it
make
is
the videos available today, please, so that we can go through it before tomorrow.
Yeah. Shortly, I will
Hello,
update.
sir.
Thank
Surely,
you.
yeah.
Excuse me, sir. Sir, when I run the this code, I'm getting my plot, but I'm not getting in my data in console. So could you please show
So
like
maybe it is a problem of either your network or system, because from last 2 hours we are running some different things.
Yes.
Okay, so sometimes what will happen now, sometimes that commands will run, but that output file, that software will not able to show in the console. So better just close everything. Now take one small break. After that, just you can just try to run this code. It will come.
Okay, sir. Thank you.
Sir, it is
Excuse me.
requested to please repeat the yesterday's class in short tomorrow, if you get some time, sir.
Okay.
Please.
No problem,
Excuse
ma'am.
me, sir.
Thank you. Thank you, sir.
Excuse me, sir.
Yeah.
Sir, is it possible to analyze the quantitative and that qualitative data together? Or we have to analyze separately both?
So just what I told just now. So if you have morphological data, so if you will convert that into codes, so you can analyze like this. You can do analysis like this PCA things. But for that, you need to convert that morphological data into numerical format.
Yes, sir, I got it, but I want to ask that can we analyze both this quantitative traits like plant height with that qualitative traits like plant color all together and form a one PCA
So
diagram?
what I will do, I will convert that qualitative data I have into numerical format, and tomorrow
Okay,
combine
sir.
and separately both we will run.
Okay, thank you, sir.
Okay. So regarding recording, I will update you very shortly.
Okay, please. Thank
So
you.
whether we have to save all these things in our software or
No need to save, because Excel file data and codes will be with you. So no need to save it.
okay. Thank you.